students, welcome to my class. In this class, I am going to discuss the topic integral calculus, which is module 4 for ENC and ENE branch students, 22 scheme syllabus. So, in this module 4, we are going to discuss the integral calculus. Yes. So, outline of this module. Here you are going to study this module in two sections. One is in the first section multiple integrals. Yes, multiple integrals. In this first you learn evaluation of double and triple integrals, evaluation of double integrals by change of order of integration, and evaluation of double integrals by changing into polar coordinates, and then applications to find area and volume by double integrals. This is in the first section. In the second section, you are going to study two special functions, beta and gamma functions, their definition, properties, relation between beta and gamma functions, and some related problems. So, this is outline of this module. Now, we'll study these concepts one by one. Let's start with multiple integrals. Multiple integrals means what? The name is itself tell you you are going to perform integration not one times, more than one times. The meaning multiple integrals. Yes. Already you know the definite and indefinite integrals of function of single independent variable along with their applications. Now in this module you are going to study for a function of 2 and 3 independent variables along with its application. So first let us see what is double and what is triple integration. So for this we need to consider a function of 2 and 3 variables. What it is, multiple integral process is what? It is nothing but repeated process of integration. That's it. So in this topic, we discuss repeated process of integration. That's it. Repeated process of integration. As I said, you are going to deal with double and triple integration. Integration is for what? Integration of or for a function or the function of 2 and 3 variables. 2 and 3. Which type of variables? Variables. Yes, independent variables. Yes. For double integrals, how will you represent double integrals? Double integrals can be written as double integration f of xy is the function with two variables, independent variables into dx dy. So integration of double integration of f of xy dx dy. So this first integral, this is related to dx. This is first one and this is second one. First integral sign is for second this variable. Second integral sign is for this. We have to integrate from inside. We have to eliminate first this, simplify first this integral, then later we have to integrate outer one. Similarly, for triple integral, triple integrals, triple integration f of No, there are three variables f of x, y, z, then dx, dy, dz. Yes. First, you have to integrate with respect to x, then with respect to y, then with respect to z. So you can write dy, dx, dz, or dz, dx, dy, like anything. With respect to that, you have to integrate. That's it. So to solve or integrate this, the main principle what we follow is what? It is the process of partial differential equation. Partial differential equations ಅಲ್ಲಿ ಏನ್ ಮಾಡ್ತಾ ಇದ್ರಿ? We used to take two variables. Yes, two variables ತಗೊಂತೀವಿ. Suppose x and y ತಗೊಂಡ್ರಿ ಅಂದ್ರೆ when you are differentiating the function with respect to partial with respect to x ಅಂದ್ರೆ y x as constant, or whenever you are differentiating partially with respect to y, then x acts as constant. In the same way, whenever you are integrating with respect to x, dy and dz acts as constants. Whenever we are integrating with respect to y, integration with respect to y, dx and dz, there is x and z acts as constants. Similarly, whenever you are integrating with respect to z, x and y acts as constant. This is the integration partial differentiation procedure we adopt here. Yes, that thing you have to keep in mind. Yes. Whenever you are integrating with respect to x, other variables acts as constant. So I am just saying this is the important one, the principle of partial differentiation is adopted to simplify these integrals. Now we'll see some of the examples. Some simple examples. How to simplify. Suppose if you are given with a double integration x plus y dx dy. So how to simplify this? As I said, first we have to integrate with respect to x. So first integral, we keep it as it is. Now integration of x plus y with respect to dx. How will you write? If you are not able to understand, one more time we write x into dx plus open the bracket y into dx, yes, in dy. This dy with respect to this integral. This as it is dy. Now x into dx, integration of x dx is we are integrating with respect to x. So x square by 2 plus yx is a constant. Integration of dx is x, yes, into dy. Now integrate with respect to y. How you write this? X square by 2 or 1 by 2 x square dy plus x axis constant now x into y into dy. So this is nothing but again x square by 2 integration of x square by 2 integration of dy is y plus x as it is integration of y is y square by 2. Now among these two x y by 2 is a common. So in the first term you will left out with x, in the second term you will left out with y. So this is the solution. This is how to solve integrations. Yes. We'll see one triple integral. Yes. Triple integral with limits. X varies from 0 to 1, y varies from 0 to 2, and z varies from 0 to 3. Function is x, y, z. Since here first integral is z, So obviously it is dz, dy, dx. How will you simplify this? First two integrals as it is, x 0 to 1, y 0 to 2. You have to integrate first with respect to z. Whenever you are integrating with respect to z, x and y acts as constants. So keep them as it is. Integration of z is z square by 2, but you have limits. So limits varies from 0 to 3. Remain this one dy dx. Yes. What it implies? These two as it is 0 to 1, 0 to 2. Whenever you put the limits xy by or upper limit minus lower limit, 3 square by 2, 9 minus 9 by 2, and this is 0 into dy into dx. Then this is equal to x varies from 0 to 1, y varies from 0 to 2, and here 9 by 2 is a constant. Yes, 9 by 2 x y into dy dx. Now we have to integrate with respect to y now. Now 9 by 2 x as a constant. So x varies from 0 to 1. 9 by 2 x is a constant. Yes. Integration of y is y square by 2. Limit varies from 0 to 2 and this is dx. So what it gives you? X 0 to 1, 9 by 2 x. Now put the limits. When you substitute the limits, it is 2 square 4 by 2 minus 0 lower limit into dx. 4 by 2 is 2 and this 2 will get cancelled. We write one more step, x equal to 0 to 1, 9 by 2 x. For your convenience, I am writing it in detail, 2 into dx. So 2 to x. So you will left out with only x varies from 0 to 1, 9x dx. So now integrate with respect to x. 9 is a constant, then x square by 2, upper and lower limit are 0 to 1. Yes. So it is 9 by 2, upper and lower limit 1 minus 0. What is the answer? The simplification of this triple integration is 9 by 2. Yes. So when you solve this integral, so it is 9 by. This is how to solve the given double or triple integrations. Now we'll see geometrical meaning of these double integrations or triple integrations. How geometrically you can represent or the given integrals is what they represents. That we'll see one or two diagrams is geometrical meaning. Suppose you are given with double integral x equal to a to b and y c to d f of xy dy dx. This is your given integral. Yes. So can be regarded as an integral. Yes. The integral. So it represents over the region bounded by over the region bounded by the rectangle. So bounded by the, so with sides, since it's a rectangle, this represents this variable a, b, c, d represents the sides. With sides, x equal to a, x equal to b, y equal to c, y equal to d. How it may look geometrically, how you can represent this in a two-dimensional plane is, if we have a sphere, yes, this is a sphere, then this is the region bounded by this. So here this represents x equal to a, x equal to b is a straight line. I'm not able to draw these lines straightly. So c, y equal to d. Yes. This is how you can represent the given integrals. Yes. So now the integral can also be evaluated by writing in the form means by interchanging values, limits. You can take this as a first integral, then this as a second one. So the integral can be evaluated by interchanging. So the integral can be evaluated by writing in the form integration y varies from c to d and x from a to b. Then our function f of x y. Now here it changes. There you wrote dx dy dx. Here it is dx dy. Yes. And whenever you simplify both, the value will be same. So this is what this is. We can say that when the limits are constant, the integral can be evaluated in either way. Whenever you have a constant limits, then you can evaluate any of the way. That is your convenient. The answer will be same. Suppose this is one type. So whenever you have what you have learned from this, when the limits are constant, the integral can be evaluated in either way. Why I am telling this? Because this will be helpful while solving examples. Yes, you can choose any way. Now, suppose if if R is a region, if R is a region of xy plane which is bounded by the curves, you can take two curves. There are two curves y equal to y1 of x and y equal to y2 of x. Let us take two curves and the lines x equal to a, x equal to b. If this is the, how you will write this notationally, we can write it as double integral over region R f of xy dx dy. What it represents? If it represents two curves. So what are the limits? X varies from a to b and and there is curves or what y varies from y1 of first curve, second for y2 of x. So f of xy dy dx. These are not constant limits. So how you can represent them geometrically? In xy plane, what we have mentioned, we have two curves. Yes, one curve, single curve. Yes, A, B. This is the region R. This is F. This is E. Yes, here it is x equal to A and x equal to B. So x equal to A, x equal to B. Two lines. Yes. Now in this AFB, this y equal to y1x, where we have written in the lower limit. Yes. So that's why in the graph, this figure also, this lower part represents the y1x. Yes. Now here y2 of x upper limit is this is y2 of x. Now further the integral can also be expressed in the other form, as in the previous one we did interchange the values in the with the constant limits. Here also you can change, but you must be careful. But whenever you change the limits, x term to y and x and y terms, here y expressed in terms of x and x in terms of constants a and b. You can write it in other way. You can write it in other way, like x can be expressed in terms of y as a function of y, and y can be expressed as the limits from limits as with the constants. How you can write? So just we'll see that the the integral can also be can also expressed in the form that is double integration over a region R f of xy dx dy. This can be written as I said in the above here x is expressed as constant limits. Yes. Now we'll express y as y for constant limits c and d, and y is expressed as function of x. Now x will be expressed as function of y, that is x1 of y, x2 of y, f of xy dx dy, because first integral represents the x limits. Yes, that's why dx dy. Now for this your graph will be changed, because now we have curves x1y and x2y. Yes, x1y and x2y means what? This is our region R, A, B. Now y coordinates, y lines. Yes, this is y equal to d, y equal to c. And now x1y and x2y. These are left part, right. So x1y is CAD. Yes, here CA. This is the points here. So this part CAD is x1y. Right part CBD is x2y. Yes. So where or will represent here only. I will mark it here only. CAD. This left part is x1y and the right part is x to y. Understood? And y varies from c to d. It should be observed that what we did, if the function of x is involved as a limit in the double integral, here function of x is involved as a limit in the double integral, it corresponds to y. Yes, it is expressed for y. So, we have expressed y in terms of x, in which case the limits for x will be constant. Here, this one, the limits for x will be constant. Similarly, the similar argument holds for this also, means whenever y limits are constant, if the functions, the limits are expressed in terms of y, means x is expressed as function of y, yes, x1y and x2y, and then also it is holds good. The same thing holds good for function of three variables also, means what, for triple integration also. For triple integration also, both the first one and the second one, these two arguments holds good for triple integration also. Yes, for example, suppose we have a triple integral. Yes, x varies from a to b. X is, it has a constant limits, and if x has a constant limit, then y will be expressed as function of x. Yes, y1 of x, y2 of x. Since we are expressing the triple integrals, then third one, z is expressed as function of both x and y now. So, z equal to z1 x comma y and z2 x comma y, function of three variables x, y, z. First one is z, so dz, dy, dx. Understood? One is constant limits, another is function of this constant limit, and third integral is function of remaining two limits. This is how to write the triple integrals. In the next class, we'll solve examples on these double and triple integrals. We'll see how we are going to use these all properties solving the examples. Till then, take care. If you are not subscribed to my channel, subscribe for further videos notification, like, and if you have any doubts, comment in the comment box. Till then, take care. Thank you.